Okay, just to wrap up our discussion of acid and base strength, well, one of the ways to look at acids is to classify them according to their composition. So here are, I think I have 4 different categories here. There are the binary acids. The binary acids, if you take this apart, binary means 2. That means 2 elements in this case, and one of the elements has to be hydrogen. So if you look at the 3 examples I have here, they all start with hydrogen, and then what's true about the other particle here? If you notice that Cl, F, and S, you may note that they are all nonmetals. So a binary acid is a hydrogen together with a single element. Notice that's for the case for all of them here. Hydrogen with a single element, and all nonmetals. Now the next category are the oxyacids. The name tells you a lot about them. They've got oxygen in them. So they start with hydrogen. Notice for all of these that I've given you, for example, they start with hydrogen and they end with oxygen. See that? And in the middle, we've got things like nitrogen and sulfur and phosphorus. If you look to a periodic table, let's see what those have in common. They are, again, nonmetals. Now, the number of oxygens here, you basically just have to memorize that. There are some tricks you can use, but basically you just have to memorize some of these formulas. All right, and the final one here is, I guess I only have 3 categories, is the organic acids. Now the organic acids are a little tricky to work with because they don't start with hydrogen. You have to recognize them instead by the fact that they have this group attached to their formula, the COOH, which is called the carboxyl group. Organic chemistry is a little different than what we're used to. They have slightly different rules and they do things slightly differently. So this is the carboxyl group, and so I grabbed a couple of examples of organic acids you might be familiar with. This is acetic acid. Here it is written as a semi-structural formula. Notice that organic chemists write slightly differently. Here's how we might see it written in our standard notation. So you see it both ways here. If it's written this way, it's easy to recognize it's got a hydrogen out in front of it. But if it's written this way, you may not recognize it because you've got to spot this COOH. Acetic acid is vinegar. Vinegar is a weak solution of acetic acid. Acetic acid can be stronger, I'm sorry, not stronger, more concentrated. Vinegar is something like 3% acetic acid. So it has that very strong vinegar smell. And then this is formic acid, which is the simplest organic acid. Notice it has the COOH. Now, and strangely, this H out in front is not the one that ionizes. This is the one in the back. Excuse me. So this is an organic acid, and it gets its name from where it was first discovered. And it was discovered in ants, the insect ants. And when ants bite, the pain is caused by the fact that they give you a shot of formic acid, because formic acid is found in ants. It gets its name from there. All right, so there are 3 categories of different kinds of acids, so you can recognize them when they come up in equations, and then we'll also do some work with these as we go forward.